This is a quick video reviewing how to run an independent samples t-test using SPSS. So this gets a little bit more complicated. What an independent samples t-test allows you to do is to compare two separate samples to each other. So this often, looks like comparing gender, so males versus females, maybe creating two separate groups based on some kind of criteria like age, under 30 versus over 30. And the important thing is that those two samples must be independent of each other, so they don't have overlap between the two. Alright, so here we have an example looking at some midterm and final scores for a class. If we click down here for variable view, we can get more information about these different variables. So here we've got a class, and the way that they're split up into two separate independent samples is by when the class takes place. So some students are in the morning class and some students are in the evening class. Then we've got their midterm scores and their final scores. So let's say we want to compare the students' performance based on what time they attend this class. And let's start with the midterm scores first. So to run the independent samples t-test, we'll analyze, compare means, and then independent samples t-test. And then we'll get this box. So we're going to put our dependent variable in this test variables box. So let's start with midterm scores. And then our grouping variable is going to be what time they have the class. So we'll take time of class, put it in grouping variable. And as we saw earlier, 1 stood for morning, 2 stood for evening. So we must define the groups to tell SPSS how to break those two groups up. So you should get this define groups box after you click define groups here. Group 1 will be the morning class, group 2 will be the evening class. And it really doesn't matter the order that you put them in as long as you keep your comparisons straight. Alright, so we've got all our information here. Just like with the other options for the other types of t-tests, you can click options and change the confidence interval that you're interested in. If your alpha is set at 0.01 or you're asked for a 99% confidence interval, this is where you would change that. Okay, so we should be good to go, so let's go ahead and run the analysis. And here is our output. So here we have the group statistics. We can see that 174 students are in the morning class, 144 are in the evening class, and then you have their separate means, standard deviations, and standard errors. So here's where you can pull that information to report for your APA write-up. Then we have an extra step. First, we have to look at the Levine's test for equality of variances to be able to tell which out of these two t-statistics we need to report. Okay, so this is testing for the equality of variances, and if this value is significant, that serves as a kind of red flag. Something's wrong, okay? That's when we would go down and say equal variances are not assumed, and we would use this row of information here at the bottom. Now, if this is not significant, if this is okay, then we would say, all right, equal variance is assumed, and we read the top, okay? One good way to remember how to do this is if this is bigger than 0.05, so bigger than 0.05, read the top line. If this is smaller than 0.05, read the bottom line. All right, so in this case, it's not significant, it's bigger, so we'll read this first line. These are the numbers that we'll use. Okay, so we've got here, we can see that there is a significant difference. The p-value is less than 0.05. It's actually even less than 0.01, so it's significant at an even more stringent value for alpha. And our t-statistic will be negative 2.636. So this might change if you put your variables in the opposite direction. So if you put group 1 as the evening class and group 2 as the morning class, you might get a positive number here, but the magnitude of the number, or the actual number itself, should stay the same. All right? So what does that mean? That means that when you take when you look at the differences in the means for the morning and evening classes, they are significantly different, and the evening class has a higher mean. So they did better on the midterm overall. All right? So that's for the midterm exam that they did. And then you can tell that we don't get a measure of effect size when running this with SPSS. So we have to calculate effect size on our own, but we can use the numbers from the boxes that we have up here. So here is the formula for Cohen's d that you've been given. This is, again, comparing the two means, which is everything that you're doing this semester. And you change the denominator of the formula. Instead of using pooled variance, well, you're still pooling your variance, but you're doing it a little bit differently. You'll take the standard deviation of group 1, square it, and divide it by 2. You'll take the standard deviation of group 2, square it, and then divide it by 2, and then add them together, then get the square root. Alright? So I pulled 82.2989 and 84.4792 from up here in the group statistics box. And then I got these numbers, 7.46106 and 7.19262 from the standard deviation box right next to it. And then I just plugged them into the formula and worked them out. So remember that when you're calculating effect size, you might get a negative number here, especially because the way that we did the numerator was putting the bigger number second, so we would get a negative number here. That's okay. Just make sure that you take the absolute value. That's what these two bars on either end of the number are for. So you round up and you take the absolute value. That means that you have a Cohen's d of about 0.3 when all is said and done. Okay, great. So let's do the same thing for their final exam scores. So again, what we found here for the midterm, the evening class did do significantly better with an effect size of 0.3. So to run the same thing for the final exam scores, we'll go to Analyze, Compare Means, Independent Samples, and instead of midterm, we'll take this out and put in the final scores. We'll leave this the same since we're making the same comparison. And then options should still be a default of 95%. So let's click OK. Alright, so here this second box, second set of boxes are for the final exam scores. So here we've got 85 and 92, their standard deviations and their standard error. And then we've got our Levine's test here. So here's an example of when the Levine's test does come up significant. So since this is less than 0.05, I'm going to read the bottom row. Okay? So the bottom row is where I will pull my numbers when reporting my t statistic. Again, this is because equal variances cannot be assumed here. So what I would do is report T 264.302 for the degrees of freedom. I can go ahead and put those decimals in. Equals negative 9.19. So that's my t value. Alright? And again, you can have a negative t, that's okay, because we put these in an order where we would get a negative number. We put 85 first and then 92 second. We do have a significant difference, so that means that whatever difference we see here is significant. And again, the evening class did better than the morning class on the final exam. So we would need to then calculate effect size just like we did for the first problem. So let me scroll down here. And this is effect size for the final exam scores. So I take the same formula, but I'm going to pull the numbers from the bottom set of boxes. So group 1 was 85.586, group 2 was 92.729, and I take the standard deviations from the box right next to them, square them, divide them by 2, then add them, then take the square root. I get a negative 1.01 about, and I take the absolute value of that, so it should just be a positive 1.01. Alright, so those are the different steps for the independent samples t-test, looking at two different instances, one in which Levine's test showed no issues, you could have equal variances, or you did have equal variances, and then in this situation, equal variances could not be assumed. And again, that's okay. The test makes the correction for you to be able to use those numbers. You just have to be able to figure out which numbers you need to use in each case.